Wow, 3D in Photoshop, full class, amazing. Never thought about it. You know, 2 years ago it'd be empty, right? It'd be like just an empty field, but now it's really exciting. So let's start. It's 3 minutes past 11. Got about 50 minutes. More than happy to keep this interactive. If you've got any questions, any burning questions, then just jump right in. I'll manage the time and try and keep it to time. But yeah, hopefully it'll be interactive, which would be great. How many people have done stuff with 3D in general before we start? A couple. How many completely new to 3D? Brilliant. Okay. And how many are doing any 3D printing? Starting to? Okay. Okay, great. And people are interested in 3D printing as well? Because my two sessions are kind of linked. This morning and the afternoon kind of will flow on to each other. Okay? Good. So, my name is Richard Curtis. I work for Adobe here in the UK, and my role is around imaging and looking after the imaging products. So that's photography mainly, but also 3D and 3D printing. Okay, so that's Photoshop, Lightroom, and the services, Creative Cloud, and Photoshop for 3D. How many people are on the Creative Cloud already? Brilliant. Okay, that's good to hear. And the people who are not will convince you today that 3D is definitely the way forward and get you onto Photoshop. I'm joking. Okay, so what are we going to do today? Well, this is kind of an introductory kind of session, and we're going to talk about, 3D in Photoshop, and just give you some very basic examples on how to get going, because 3D can be complicated if you've looked at any packages like Cinema or 3D Studio Max or ZBrush or something that can be a little bit daunting. So we're going to go in through some basics and get you up and running very quickly. Move that. Okay, I can see now. Then we'll look at creating some very simple geometry. Okay, now there might be some things that I'll mention today and some terminology. If you're not clear what it means, just shout and I'll explain it. Is that okay? But we're going to create some 3D objects from simple shapes and from type. So make it really, really simple, straightforward. This afternoon will get more complicated. Then we're going to look at how to import 3D objects into Photoshop and the sort of files that you can bring into Photoshop, and some limitations and some workarounds that you might have to think about when you're doing some 3D stuff. Okay? And then we're going to look at an introduction to 3D printing, and just give you kind of a heads up on how 3D printing works in Photoshop, what the idea is, and how it works, just to kind of demystify any issues that you have around that. Q&A at the end, but more than happy, like I say, to answer any questions that you've got going through, because then it's in context, and then it'll answer your question, and I'm sure that everybody else has probably got similar questions as well, so it'd be great if you can do that. Okay, not staying in slides very long, so we're going straight into a demonstration, because we've only got 45 minutes, and actually 3D in Photoshop is actually quite deep, believe it or not. Okay, so the first thing we'll do is we'll go into the 3D workspace. Now, how many people didn't realize that Photoshop had 3D in it? Go on, be honest. Really? Does everyone know that Photoshop's got 3D?
Sometimes forget.
You know it's got a big menu at the top that says 3D, right?
If your computer allows it.
Kind of big, yeah, if your computer allows it. Yeah, so the first thing to notice, that's a good point, so thanks for that. The first thing to notice is that for Photoshop 3D, you do need at least 512 meg on the video card, dedicated video card, because of the ray tracer and because of the renderer. Okay, so you do need to know that. That's something that's important. A lot of things around 3D are going to be based around, or limitations are going to be based around how much memory your machine's got. So this has got 16 gig of RAM, and it's okay to bring in up to, say, 10 million polygons is okay. Any more than that, you're going to start feeling a bit of pain. Things won't move, things won't work, and you might experience a few crashes because you still run out of memory. Okay, so 3D is very memory intensive. Let's make a very quick canvas. So everyone's familiar with 2D tools in Photoshop, right? So the hardest thing about Photoshop, or the weirdest thing about 3D in Photoshop, is that it will use all of your 2D skills, which is very different from when you're working with, a few smiles over there, it's very different from when you're working with 3D software, because 3D software, you're not working with 2D tools, you're working with polygons, and you're working with weird tools like knives and all that kind of stuff. So Photoshop is driven around the 2D tools. So what is Photoshop for 3D and what is it not? So it's not really a modeler, okay? It's not a sculpting engine, you can't sculpt with it, that's where you need proper software. or 3D software. But what Photoshop is a finishing product, okay? And that's the same for photography. So a lot of people say, why is 3D in Photoshop? Because people want to finish their comps with 3D objects, okay? So it's a pure finishing tool. However, that doesn't mean that you can't create 3D objects in Photoshop. So let's do something very simple. I'm going to use a quick shape, okay? So I'm going to draw out a simple square and then convert it into geometry. Okay, so nice and simple, just to get us going. And the way to do that is, once you've drawn your rectangle out, just go to the 3D menu and choose either 3D extrusion from layer or 3D extrusion from path. And once you do that, Photoshop will go and ask me if I want to change to the 3D workspace. I would recommend that you do that because it will give you all the tools that you need. Okay, I'm going to keep no because I've got my own toolkit, the own space I'm going to use. And it will create me geometry. Now, a lot of people, when they first looked at 3D in Photoshop, when it first came out in 2004, got very excited about it, but then soon, kind of experienced its limitations. It didn't do 3D very well. It was a bit wonky. And it also had, some issues around the creative workflow. So it didn't create things like ground planes properly. It didn't create lights properly. It didn't create, materials and all that kind of stuff. Well, thankfully, since CS6, that's gone away, so the workflow and the experience now is really much smoother, okay? Not to say there's not any kinks, because there are a few kinks, but you can work them out, and actually, it's pretty easy to work with. So here we go, very simple piece of geometry. Let's have a quick whiz around the 3D menus. Now, 3D applications are normally quite complex, have a lot of menus, and what we've tried to do in Photoshop is make it really easy for people to get into it. So in fact, there are only 3 panels in Photoshop for 3D. First of all, you've got the layers panel, and everyone knows how to use the layers panel because it's standard kind of bread and butter stuff for Photoshop. So you've got the layers panel here, and you've got a 3D layer. The 3D layer will show us any attributes that 3D object has got, or that 3D layer has got. So any IBLs, image-based lights, any materials that are based on there, and the object itself. You can turn them on, turn them off, or you can collapse it down. You may have multiple layers. So Photoshop hasn't got an inherent global coordinate system, kind of world-based system, but each layer has its own kind of world and its own kind of content. So you can have multiple 3D layers inside your comp, and each layer has got its own world system, okay? The 3D menu itself will tell you more information about what's in that panel and what's actually on the screen. So what you've got here is you've got an environment. So the environment links to properties, and the properties will tell you and let you control the properties against that attribute. So for example, in environment, you've got control of your image-based lights, you've got control over any colors of your image-based lights, your shadowing, your reflections on the ground plane, and your shadows on the ground plane, okay? You can also go and create your own IBLs. So when I say, it's linked back to your 2D, believe it or not, anything in Photoshop around 3D and materials and lighting is all around masks. So you know how to use masks, right? So you automatically know how to use materials and how to do stuff like this. So you just basically draw out what you want. Black restricts the light, white lets light in. Simple as that, right? Really, really simple, straightforward. The scene will give you access to stuff like how the model looks on the screen. So you've got cross sections. So if you've got an architectural building that you want to show half of it, you can put a cross section through the middle of it and get away one half of the building, and then it will show you what's inside that object. The surface will tell you or show you how it's looking to the camera. So solid will show you all the lights and how the faces are reflecting the light. If you turn on unlit, and we'll talk about unlit this afternoon, unlit will give you an unlit view. Okay, that's important when you're painting, right? Because you don't want to have lights on when you're painting because you might be sampling colours. You also have things like normals. So, in 3D land you have normals. Normals are basically the polygons and the direction of the polygons and the faces, so they're facing. So we have that type of thing inside Photoshop as well, so you can see what's happening over there. Unlit texture is kind of useful. Obviously you can't see geometry when you have unlit texture turned on because there is no geometry to show. However, you can turn lines on, and lines will show you the geometry, so you can work on, we'll talk about it later on. And you've got points to show then your vertices that you have inside that object if you have any. Okay? Current view is the camera. Infinite lights are the way to manage the lights. So here's the light source. You can see the light source in the top right-hand corner, and I can move that light source around just by dragging the widget around. And if I've got shadows on, it will show me any shadows on the ground plane. If I click on the light, I will then get to the properties of the light, and I can then modify the intensity of light. Hang on. So nothing's happening on the screen, right? That's because I'm in unlit mode. So if I go change that back to solid, you can see now that the light will change and the shadowing will change based upon things that are going on. So everything's in real time. Okay? You've got multiple lights, you've got infinite lights, spotlights, point lights. You can pull them in and you can direct them and you can work with that as well. And then you've got the object itself. The object itself you can click on. Now, if you've got multiple shells in here, is everyone familiar with the term multiple shells or familiar with the term shell? Okay, so think of this object as a shell, as a single shell. It's a group of polygons all put together. When you're putting a comp together, it might have multiple shells. Say, for example, if you designed a person and it's got a hat on, like this gentleman in the front, its hat might be a shell, head will be a shell, the body will be a shell, neck will be a shell, arms, legs will be a shell. All individual components, when you bring it to Photoshop, they will all stay as individual shells. It means you can turn them on and turn them off, and you can work with those isolated instances on their own. It might be a whole shell, so he might be a whole shell, it's just one thing, and then you bring it in and you have one object like I have here. Okay? The rectangle itself in here has got multiple sides on it, so it was created just from a single shape, but it's got a front extrusion, it's got a back bevel, it's got extrusion material, and these are just standard stuff that Photoshop creates. Now, when you bring in an object from the outside world that we'll look at in a few minutes, it will bring in a material, and any materials that are associated with it, it will bring the materials in as well. Okay, so if you're designing in something like cinema, and you've got materials on the object and you bring it through, you will get those materials come through inside Photoshop. So you can carry on working. Or you might want to paint and do something in Photoshop later on materials we'll talk about later. To select that, you can just select it and then you'll get the properties of the material. Again, the properties panel, you can see the materials for this in this face. In this face, we'll talk about later on, but you've got a set of materials here, but you can build your own materials. I mentioned about 2D, right? Materials are based on 2D, so all your 2D skills, we'll look at it later on this afternoon, but your 2D skills will come into play because everything is built from 2D. Okay? So it makes 3D really easy and really accessible. The other thing to notice is the cage. When you click on an object for the first time, you get this little widget. The widget's quite handy. It's going to give you interactive controls of the object that you're pointing at. So this is objects now, and there's two things to think about in 3D. You've got objects and cameras. So the cameras are the kind of what you're seeing in the view, depending on what you've got in the scene. And then the widgets will pick up the shell that you're working with, and you're then able to work with that shell. So when you're working with that shell, you might want to scale it. So don't worry about the polygons for the moment. Keep the polygons aside, because you don't really ever work with polygons inside Photoshop. In fact, you only ever see that word once, twice actually. One on the information panel, where it will tell you how many polygons are in the mesh. So you can see there in the information panel, 22 polygons in that mesh. Okay? And the other time you see it is when you try and simplify a mesh, or what's called decimate a mesh, and we'll talk about it a little bit later on this afternoon. So things I might want to do here, I might want to scale it. So if I just use my mouse, I can scale it. Now notice I haven't switched any tools. Okay? So I can work with my objects inside my 3D panel, and I can rotate, and I can move the object around. I can even squish it and scale it and put it into position. But I'm not using any tools. I'm just using my mouse. And if I'm using a Wacom tablet, just use my tablet to move things around. And that's because everything in 3D is actually on the Move tool. Okay? So the whole infrastructure around working with objects in 3D is just on the Move tool. In fact, there's only really two tools you need for 3D, and that's the Move tool and the Brush tool, which we'll talk about later on. There are other tools we can use as well. We'll talk about that later on as well. It gets a bit more complicated. We've got camera modes here as well, so we can move the camera. However, I would refrain from using these, and I would use these that are available in CC. Okay? So these offer you a way to move the camera. Now, when you're working with 2D and you want to zoom into something, zoom into a canvas, how would you do it? Command plus, command minus to zoom in? So in 3D, refrain from that. Okay, because what you'll get is a rasterized image of the 3D object. Now, you don't say you can't do it, because you can do it if you're working with some fine detail work, but a better way is actually just to dolly the camera. And dollying the camera will move that object closer to the camera, then you can work with it in 100% high res. You can also move the object around, so if you pick up the pan camera, you'll move the camera up and down, left and right. And you've also got orbit, so you can orbit the camera and move it around. So there's definitely a shift in how people are using 3D now in design, because it means now that if you're working with something in 3D and the client asks if you can move it around a little bit, in 2D you have to repaint it. But in 3D, you just move the cameras and then re-render it. So there's definitely a shift into the way that people are working with that. Now, a couple of things to consider when working with 3D on the preferences. So when you're working with 3D, on the 3D menu down here, this is going to control how much RAM Photoshop is going to use. If you give it all of it, it will eat all of it. Okay? And you're soon going to run out of memory, so I would just dial that back a little bit. I would also, to get better performance, I would remove the shadow quality and put it down to very low, because when you're working with 3D, you don't really see what the high-res shadowing looks like, okay? Because you just want to move things around. Then when you render it, you'll get a high-res shadow. Ray tracer, the high-quality threshold, to be honest with you, 5 is really high. That's going to take a long time to render a scene, so I would turn that to be a 3 or a 4. That's probably enough. One of our guys, one of our designers, actually kills his render halfway through because he likes that organic texture that it makes when it's halfway through a render, okay, which is very different to something like a Cinema or a 3D Studio Max or something like that. So you can kind of get your creative edge based upon different things that's happening inside Photoshop. Okay? Any questions so far? Simple enough? Yeah.
Is it the number of bounces that you reduce just from 5 to 4? Is it the number of bounces?
How do you mean number of bounces?
Well, Ray Tracer calculates the shape by bounces, the number of bounces.
I'm not sure, but I can find that out for you. I'm not sure off the top of my head. So let's look at doing another object very quickly and show you a couple of options. So we've got a solid object there, but what if we wanted to make something that was just a box with a hollow edge? So we can just use our 2D tools. We can turn off the fill and put a stroke on it, and this will give us just a very simple rectangle with an edge, okay? So we can also convert that to 3D as well by selecting the layer or the path, as long as it's got an alpha channel to it, and it will create us a hollow box. So different options there. Now, you can also create 3D objects, believe it or not, from a Bezier curve. So if you put a curve in place, whatever it looks like, and then you create that object, you can create it from the path, and it will go and create you 3D geometry from that path. Okay? Now, any of these faces can be turned off, or the materials can be turned off in the 3D panel. You just select it and you can turn off that material if you wanted to do that. You can also, if you go to the properties, to get them more complicated, you've got the properties for the material. So if you want to make something opaque, you can by just dialing up the opacity. And if you want to put a map on there, a black and white mask, it will then mask out certain parts of that geometry with that mask. Okay? Let's make some type very quickly. Introduce you to the type tool. How many people are using Typekit? Cool. Okay. So if you're using Typekit, this also applies. What's interesting about the type is that we actually have a 3D menu right on the type tool. Okay, so if you're in type already and you put some type on the screen, hit the 3D button and it will convert that into geometry. Nice and simple. Okay, now the cool thing about it is that if you're working with Typekit, then any of our objects that are created from a 2D source, if you click on the object, you'll see in the properties panel you've got edit source. So now you're working with something called parametric, which means that I can change these objects at any point in time. It's not a raster, it's a vector object. So if I click on the edit source, it will open up a canvas, and that canvas will be the PSB. Okay? One more second. Hopefully. It will open up the PSB, and the PSB will contain just the 2D text that we can then modify and change. And then once we save it, come on. Once we save it, it will go and then alter the geometry back into the 3D. So I can keep altering it and saving it as a PSD as long as I like, and I've got complete control over what that says. Here we go. So there's my PS. If I want to change that now and put that to PT, all I have to do is save it. Control S to save it and go back to my geometry, and now it changes it. Okay, so really quite simple stuff. If I want to bring an object into here and do something with that 3D object as a unit, I can load more things. Yeah?
Just one quick question. What if you change the distance between these two letters? It will still be two shapes, but there will be overlapping. So it will appear on my 3D object as they are being pushed into one another.
Correct.
Is that still two shells?
It's one shell.
That is one shell.
That's one shell.
It's not, it's not two. It's not one for the P and one for the T.
No. So if you create text like that, it's one shell.
Yeah.
However, what you can do, if you want to do, and you would lose the editability, is actually what you can do is you can split the extrusion. When you split the extrusion, you will then get two independent objects that you can then work with.
Yeah, that's
okay, so but you'd lose the editability of that.
Cool. Thank you.
Okay? Yeah. So you can then move it around and create something quite interesting. If you want to bring something in, you could then say new 3D from file, and then you can open up, which opens up your objects. Now, there's a few things we can bring in. I'm going to bring this guy in over here. So when it comes to formats, we support quite a lot of formats, native formats. So we support STLs, obviously, because STLs are good for print. We also support 3D Studio Max as a native format, Collada. How many people use Collada? Yeah, cool format, really cool format. And the reason Collada is a cool format is because it contains animation, and it also contains cameras. Okay, so Photoshop will preserve the cameras and animation if you bring it in. Okay, so if you've got an animated character in an A pose or a T pose, and you've rigged it, you can bring that animation in. It will play on the timeline. Okay. Flash 3D, Google Earth, iGES, PLY. PLY is a scan data format, so you can bring in scan data now. You've got PRC, you've got STLs, U3D, VRMLs, and OBJs. So the ones that are really exciting are OBJs, VRMLs, U3D, anything basically but STL, because STL doesn't contain any color. So when you're working with Photoshop, you obviously got color that you want to think about, and we'll talk about color later when we talk about 3D printing. But just to say that we support quite a lot of native formats. We also support Cinema 4D. There's a plugin on the Maxon site you can download, and it will bring in C4D files as native objects, which means that you've got a nice way to edit in Cinema and then bring it across and carry on working in Photoshop. So let's just bring in this guy over here. What you get when you bring an object in is you can see the size of the object, the physical size, the X, Y, and Z size. So you need to think about that, because when you're printing, you shouldn't really go over the size of the physical object. You can kind of tweak that a little bit, so we'll talk about it later on. So I brought him in now, so he's now in a separate layer. If I look at my layers panel, I've got on my first layer, I've got my text, which I can switch to, and on my second layer, I've got my donkey guy. I've got this King Kong guy. And I want to bring them together and have them in the same world, because at the moment they're on different levels, so I can't have them lit the same way, and I can't have them interacting anyway at all. I might want to have the monkey on top of the T, for example, and it's going to be hard to do that right now because it won't be on the same render path. Okay? So to do that, there's a couple of things to think about. One is, if you set your lights up, and you've set all your image-based lights up and all that kind of stuff that you've done, you don't want to destroy that, okay? So when you merge these two together, you've got to be careful of how you merge it. So the first object that you click on to do the merge should contain your lights and your lighting rigs, okay? Then select your second layer that you want to pull into that layer, and when you click on 3D, merge 3D layers, it will throw the lights away of the merged layer, but keep the original lights intact, okay? So now I've got the little guy over here. You can see how big those characters were. They were pretty huge. So I can now scale this guy and put him where I want him. Now, of course, we do have other views. So we do have a secondary view, which is really handy when you're lining things up. So secondary view means that I'm going to work in something called orthographic view rather than perspective view, which means that now I can place him where I want to and get a more accurate placement. So I can put him over here on the T, and you see it moves in the secondary view as well, so you can see what's going on. If I go to the front face, you can then get a front face view, and you can see it's a little bit wonky, but if I click on him, I can then put him into position. It may be that he's a bit too big for that T, and that T will fall over, so maybe I want to just put him down. And then what I can do is I can rotate him into position. I also have coordinates as well, so if I want to get him exactly right, I can just type the coordinates in, and it will put him exactly where that needs to be. So I can control it manually, or I can rotate him into position, and now you've got this dude on a...
Why did you merge the layers? You didn't merge the layers,
Right, so why did I merge the layers? So when I'm working with 3D, I might want to do something like this, which is I want to have an object on another object, or the objects colliding together and doing something interactive. So when they're on separate layers, they can't do that because the Photoshop, by default, hasn't got a world-based system for all the 3D layers. Each layer has got its own coordinate system, so you need to merge them in together. Okay. So here we've got this little guy over here. Now it might need to be that I want to print it. So I'm just going to introduce you to a bit of printing now, and we're going to have a go at printing him. So people that have been involved in 3D printing, any problems with this scene? Yeah.
Overhangs.
Overhangs, right. Anything else? Any problems with 3D printing? Intersecting meshes, anything else? What about holes? About wall thickness?
I think it's the water pipe.
I don't know, is it?
Maybe the gorilla is.
Yeah. The thing is, you don't know, right? You don't know. So I was listening to a couple of guys out there. Who was out the front? Who was out the back just now? Who talked about when he's designing in 3D, he builds a surface and then he duplicates it, and he flips it around and joins it back again. Who was talking about that? No? Okay. So one of the things that designers do, because designers love working with geometry, is they'll design half of it, and they'll copy it, and they'll paste it back in again, move into position, and then join them together. Mirror it, yeah. Is that printable? No.
Depends if you join them properly.
If you join them properly,
it's
yes.
a modifier that mirrors it, and then it's if you apply it.
Right, if you join it properly, yeah, but most of the time you're going to get what's called an inverted triangle. You're going to get polygons at the wrong way, and it's two meshes, and you can't print two meshes. So the thing is, you don't know, you're not sure. So that's what makes 3D printing hard, right? 3D printing is challenging because you don't exactly know what's going to happen when you start printing. So most of the time people, let's take a little FDM printer, a little Ultimaker 2, for example. Ultimaker is a great little printer for about £2,000, sits on your desk and it'll make stuff. But what happens is you start making stuff, and the way it works is that it lays down plastic, and that plastic is laid down, and then at a certain point it will finish the print. Now, so when you're printing something like this, let's just move it into the 3D print pipeline so we can see what's going on. The 3D print pipeline in Photoshop is available through the 3D menu under 3D print settings. This is the start of our 3D print pipeline. Okay, so the first thing is, he's massive, it's huge, right? What you're seeing here is you're seeing the bounding box of the 3D, of the bed or the chamber that you're going to print this object in. Making sense so far? Yeah. Okay, good. He's too big, he won't fit in. So if I ask it to print now, it'll say I can't print it, it's too big.
Where do you define the bed size?
I'll come to that in a second. Because what you have in Photoshop is hardly any control. Right? I've got no control in Photoshop about the print. Now if you're used to 3D printing, you're probably going to be using something like a Cura, or you might use third-party software from the printer manufacturer, and you've got to dial all this stuff in yourself. Okay? So what we said in Photoshop is, we want to make it easy. Like the gentleman over there said, you know, really, you don't really know what's wrong with the mesh until you start printing it, and then you might get problems. Now, this is going to be, I think, about a 10-hour print at high quality. It might be a 2-hour print at low quality. However, I can start printing it, and then an hour through, or 2 hours through, the print will fail because I haven't supported it properly, or it's got holes in the mesh, or whatever. So I have to manage it. Now, you know, as a tinkerer, then that's fine because you're going to have time to play with it. But if you're in a design agency and you've got hard pressure with a client, you know, they're going to want to have something when you said they're going to have it. You can't just say, well, the printer's broken down, or, yeah, you know, the print failed after 25 hours, so we're going to have to do it again. Right, that's not going to go. So we've designed this in a way that it automates the whole process from front to back, so it takes that whole headache away. So you can see here that I've got the Ultimaker 2 selected. We do have a list of printers in there. And actually, you can make your own printer profile. I'll talk about that in a little bit as well. So we've got multiple printers in there. I've got a few things in there that aren't kind of available yet because I'm working on a few printers. But you've got the Ultimaker 2, you've got a Tinkering Ditto Pro, you've got a MakerBot, You've even got some full colour printers in there, and I'll talk about that a little bit later on as well. Let's take the Ultimaker 2 though. The only controls you really have are choosing the quality settings. Do you want high resolution, medium resolution, or low resolution? And the Ultimaker is 100 microns, 200 microns, or 300 microns. Okay? So you can choose high, medium, and low. The size is a problem, and I want to make it fit the bounding box. So rather than go resize it, I can just hit the button to go resize it, and it will go resize the geometry based upon the size of the bounding box. Okay? If I want to go further and reduce it further, I can just click on the objects. So go to the 3D menu, click on both the objects because they're both now available to me, and I can reduce the size of the objects. Yeah, okay. Where's the other one? Here he is. Click all the objects, and then I can reduce the size of them. Come on, close that down, close that. I can't do that for some reason. Okay. I can reduce the size of the object if I need to reduce the size of the object. Okay, so to print this, all I have to do is push the print button. Okay, and the 3D print, there's a few concerned faces over in the back of the room, by the way, saying this is impossible, you can't automate 3D printing, correct?
I would be very skeptical to see the result, but yeah.
Okay.
Does it generate support? Does it slice it in Photoshop?
It looks very brave. At this point, it just press print and the 3D print.
I would probably print the PT and the Gorilla print separately without support.
Okay. So we can pretty much print anything from Photoshop. You put it in the print pipeline, and it will come out and be supported, have the geometry fixed, the walls fixed, inverted normals fixed, floating polygons removed. Any supports required, it will build them as well for whatever printing you're printing out to. If you've got colour in there as well, it'll manage the colour textures. Yeah, we pretty much slice the whole thing as well if you need the slicing, okay? Okay, so what we do is we create a tree structure to support the objects throughout the print. And you can see there that as you're going up the T, you're printing the P and the T out. You get to the P or you get to the T, and you're going to have the overhangs, and the overhangs aren't naturally supported. And through gravity will take over and print them, and you'll get spaghetti, and then you get a spaghetti print, of which I've had many. But if you support it properly, and what we're trying to do here is automate the process, so you can't change the supports, okay? You can turn it off or turn it on, and you can control how it's made. But if it needs supports, we'll build the supports automatically for you to support all the objects and all the areas that need support throughout the print build. Okay? It's showing in green because I've got the show repair turned on. You can't really see it on the screen there, but green is the mesh, and this is showing me the repair. So anything in green is the original mesh. What it's telling me is that nothing in the geometry has been changed through the fixing process. Blue, if it was in blue, any walls that have been thickened. Well, why is that important? So say, for example, you want to print something like this radio, and this radio's got a very thin antenna on it, and the antenna is smaller than the minimum wall thickness of the printer that can print. It needs to be fatter, it needs to be a bit thicker. So what we'll do in Photoshop is we'll automatically thicken it from the inside, and we'll bolster it out if it needs thickening. So that's something to consider to remove if you need to remove it and print it in another material maybe.
Does that mean that the text is hollow and the wall thickness is the thinnest you can?
That's a great question. Is the text hollow?
Well, there's an idea of honeycombing.
Right, that's a great question. So when you're printing objects like this, you wouldn't want to print it solid, because solid is going to take a long time and use a lot of material. So what you have is something called infill. And you can define the amount of infill on the 3D printing profile, and you can define the percentage of the volume of how much it will be filled. You can also define how you want to fill it. So you can either use cross or cross diagonal or just diagonal. And it will basically populate the objects internally with the infill automatically as part of the process.
So what's the default?
Default on the printer profiles, we normally set to about 15–20%. It'll depend on the printer you're going out to. So the Ultimaker I've just built is about 20%, I think it is. But you can reduce it or increase it. And what it does is it will give the model, strength through the print process. Because don't forget, you're printing hot to cold, and you're going to have this cool down process. So if you haven't got infill, you might get walls collapsing and stuff like that. So you put infill in to stop that thing happening. So we put the infill in automatically and we build all of that for you. We also can provide a raft if you need a raft. So, I mean, it depends on the printer. I would normally try and print without a raft if I can get away with it. And by doing that, you're just going to get a raftless surface, and what you'll do is you'll build all the supports on the bed. Now, this is going to work great if you've got a heated bed or something like that, but actually it's going to be more problematic if you're using a printer without a heated bed. You might get some movement. So I tend to, depends on the printer and the complexity. If it's a very simple object, like a cube, I'll print without a raft. But if it's a complex object with scaffolding, I'll print with a raft, because it means that you're going to have more security of the print. The last thing you want to do is this print failing after 20 hours or whatever it is, right? So it's just a bit of security. Then the idea is that once you've printed the print, and personally I quite like all the scaffolding, right? But if you want to get rid of the scaffolding, which most people would do, you could then either take this off with your fingers or just use a little knife and you can clip them all off and they will come off in your hands. Now, if you're using a dual-headed printer, like with soluble supports, you can actually tell Photoshop to target a soluble support and a main body as well, so you can actually print both. Okay? And it looks like scaffolding looks like that. Now, if you pull a render here and a ray trace, what we will try and do is we'll look at the actual properties of the profile and the resolution, and we will then try and render that out to the user. So this is giving you a preview of what that print will look like and the resolution before you even go about printing it. So it means you can make a design decision about if you're going to print it or not based upon the preview that you're seeing here. Okay? Let's talk about slicing. So these printers, most of them take a format called Gcode, especially on the little desktop printers, okay? Single material. So you have to slice it. So things like Cura and these applications will slice the object for you. And slicing just means it will output printer positions, movement positions, and what's called retraction positions of the head against the material. That's quite a cumbersome piece of work. So what we do as part of this process is we can export Gcode. Okay? So we'll slice it and create the Gcode automatically that then you can put onto an SD card, and then take the SD card, put it into the printer and press go without even having to go through any third-party software. Okay? So we support Gcode. We've got custom exports as well, so we support X3G for the MakerBot. We also support slicing or cutting out to color prints as well, so OBJs, WRLs, that type of thing as well. We even support 3D PDF, and I'll talk about that a little bit later on. Ahead of time. Okay, cool. Any questions? Yeah.
Can you open Gcode in Photoshop? So let's say if I want to go to the layers, see when I do sometimes I change the filament throughout the printing process. Right.
So so the question was, can you see the Gcode in Photoshop? You can't see the Gcode in Photoshop, but what I would do if you're going to do that is I would go out to a third-party source, and what I've been using to do all my stuff is Gcode.ws. Have you seen this? So Gcode.ws, let me just export this. Let me make something really simple. Let me take this rectangle and let me just export this out so you can see. It's a kind of, if you're building a profile, it's kind of something you need to look at because you might want to see how the print is being built, but it also gives you an idea of what's going to happen to the object. While it's doing this, any more questions?
Yeah, just
yeah.
So I don't know anything about 3D printers, but what's the brown? What was that brown colour? That brown.
The brown at the bottom.
Yeah.
Oh, so this.
What material is it?
On a single material printer, it'll be the same material as the single material.
But the connection between my intended object and the support would be thinner, right?
Correct.
I could break it off.
Yeah, and you can change that as well.
Yeah, it's like a supporting pillar in a
supporting pillar in the main structure.
Kit
yeah, exactly. So yeah, so all that sort of stuff you can manage. So if I just look at this, this is a bit geeky, but if you're into technology, then it's something you might want to do. So what it's doing now, it's reading the Gcode in, it's reading the slices in, and this will show exactly what the printer's going to do. Okay, so if you see it now, so the first layer is the raft, because we had a raft in there. If I use the up key, the second layer is a bit of the raft, third layer, then we get into the object, and now we start building the object up. And if I use the up arrow, This is at an angle. You can see it's building from the right-hand side. It's got, how many layers? It's got 1,002 layers, so it's going to take a little while to print. The nice thing about GLWS is it tells you how much filament you might use, and it tells you how long it might print. And it also tells you the most important thing, which is the estimated layer height, which is 200 microns. So you can see here.
Sorry, what is the estimated? I can't read it.
You can't read it very well, though. It's not a very good projector. But you can see there that this is the actual Gcode. Now, if you want to see the Gcode itself, it's really geeky, but that's what the Gcode looks like. And basically, Photoshop's output all the Gcode coordinates for you. Okay? I won't spend too much time on that because it's really nerdy, but it's kind of fun. Any questions about 3D in Photoshop as an intro point? Yeah.
Can you ever work with like unrealistic 3D using like isometric or like create isometric text directly through Photoshop rather than like Illustrator?
Well, using paths.
Yeah, so like planes wouldn't it? Like 30.
I mean, you can. So the nice thing about this is that you can bring in objects from Illustrators. Whatever you bring into Illustrator, you can bring straight through into Photoshop and render it. Okay, so you should be able to do that. The other thing is, what else can you generate? So how many people use Creative Cloud libraries? Okay, and have you used the Shape app? Yeah, Shape app's pretty awesome, right? You seen the Shape app? So Shape app on the phone, if you haven't seen it.
Oh, shit.
Yeah, Adobe Shape. Adobe Shape goes and captures real-world objects and will turn them into vectors. It's pretty handy, right? So I saw a T-shirt I quite like. You didn't see this, by the way, but I saw a T-shirt I quite like with this this eagle on it. So I captured it with my phone, I drew the vectors out, shared it with my Creative Cloud library, and now the vector's available here in my libraries panel. I can then drag the eagle onto my document. Okay? Once I've got it into my document, I've got the vectors in, I may have tweaked them a little bit with Illustrator, and I've got a direct connection here with Illustrator. If I've got an Illustrator file in here, I can edit the curves in Illustrator, and it'll render back in Photoshop. But what I can do is, as long as I have the 3D layer selected in the 3D panel, I can go to my 3D menu, and I can draw an extrusion from that layer. Okay, now what I'll also do here is, when I go back to my widget, I have my controls here. So on the controls, I can actually scale this on any axis, so I can thin down the extrusion. For example, let's make a chain for a necklace, right? If I press the V key, or in the Properties panel, go across to the next section, I can then bring in my deformers. So I've got an extrusion deformer. Now I can't extrude across a face, okay? But I can extrude across the back. So I can bend this object. I can also put a twist in the object as well. And press the V key again, and this works very well with text. I can actually increase the front inflation strength, and I can also increase the bevel on the front or the back. If I just go backwards a second. Now, we partner with 3D printing companies. Now, it might be that you've got an Ultimaker or a MakerBoard or something, you've printed this and you quite like it. And to be honest, printing this, you print flat. Right. I mean, you could print upright. There's no problem doing that. You can get some weird support, but you can do that if you want to spend a lot of time. But a better way is just, which some people do like, by the way, the better way is just to rotate it and rotate it to 90 degrees, and you'll get it flat on the surface. Okay. We'll automatically manage, as long as it's not on an angle, we'll automatically manage the distance between the ground plane and the object, if it's any object in the scene, and we'll flatten it against the ground plane when we print. So we partner with some 3D printing companies and services. So, for example, we may have printed this out already on our 3D printer at home. Works really nicely. We're happy with the output. It cost us like 20 pence to print it, so that's all good. Now, we could paint that, and we could wear that. You could even make a little ring, like I showed you before in Photoshop. Little ring, put him on the top, blend them together, and then you've got a little point to put him onto your necklace, right? So that's an easy thing to do. But it may be that then, once you've finished with this, you actually want to print it in, let's think of material, solid silver, okay? Maybe you're a wedding photographer, or you're a bride and you want to have a cool design for your wedding, you want to make your own earrings or something like that. Well, you might want to print it in stainless steel. So we partner with companies like Sculpteo, iMaterialize, Shapeways, 3D Hubs, Europack, 3D Printworks, MyZ3D, a few services like that that offer different materials. Because these printers that really do sophisticated materials are very expensive, you know, and very complex and require a whole different approach to 3D printing. So we've kind of simplified all of that and said, okay, well, just all the user has to do is select the print service they want to use, and then select the material that they want to have printed in. In this case, was going to be a silver. I'm just going to, 1 second, I'll just sculpt here, so I think I might have a better one in here. Where is it? Silver polished. I've got different types of silver. I've got mirror polished, and rough. I can choose the type. You see the cage will change the size because that's the size of the bed that it would print. Much more kind of the smaller print bed. So then I can just change the size to be whatever size it needs to be. If I need to change it and be more specific about the size, and it maybe needs to be, I don't know, let's have a look how big it is. So I can see dimensions on here. If I move the cage around, you can see it's 5 centimeters wide, 8 centimeters tall. I'm going to fix that to be 4 centimeters. Dial 4 centimeters in, and then we'll change it. And then when we go to the print and go through the print pipeline, we will manage the polygons, and we'll manage the kind of reconstruction of those polygons through the print process. So I send that through to the print service now. I can just press the Go button. We then take the printer profile of that printer, because it's all been defined in the shipping version of Photoshop, so all this is available now. You choose what you want. It then applies the parameters of that printer profile to the algorithm of the fixing, and we fix that model based upon the parameter of the printer, give you an estimate price, and then show you what it's going to look like. And you can see there that it's too thin for that printer. Now that's because the printer definition is a bit too kind of a bit too thick. So what I would do is I'd go in and change it to be a lot thinner, and I get away with a lot more. But you can see there that the walls have been thickened in blue because those walls were too thin for that printer, so we've actually made it bigger for you.
Does the neck now touch the shoulders or still not?
It's disconnected.
Is it
Disconnected. But
no error warning, no warning.
that's a single shell. That's a fixed single shell, so it will print as a separate unit.
Well, would you connect it? Would you do it in Illustrator?
Yeah.
Would you just make the vectors?
So do it in Illustrator as a vector, yeah?
No control information.
Correct. Just go into Illustrator, extend that path, fix it all up, clean it.
You could go through that process from this model, right? Just like with the
Correct.
text that I could edit.
Correct.
Just not, it's not going to be a PSP, it's going to be an AI file.
AI file. Yeah. So what happened in that case is
That's smart objects.
Vector Smart Object. It brings Illustrator Vector Smart Object into Photoshop. You double click it on the Smart Object, take you to Illustrator. You go fix it up, press save, it'll come back, and then you can regenerate the 3D model.
But for holes like that, there's no error warning here.
No, it's fine. That's a single shell. You can have whatever you want in that print bed, and it's a single shell. And we manage that single shell. You can even cut something up with, you know, I showed you before about the cross-section. I'll show you later on this afternoon. We'll cross-section something out, and we'll cut it, and then we'll weld it together then later on and print it as a single shell.
And this will print in silver.
Correct.
How much is it?
Can I just say, it's interesting that you chose the silver option, and everyone's saying and thinking, awesome, where this is being sent to a machine somewhere that's going to print that in silver.
Correct.
It is not doing that. What is happening is that is going to be printed in wax, and it will be sent to a traditional caster.
Yeah.
Not always.
Yeah.
There is actually metal printers.
There are, but there's not a silver printer.
No, it's not going to melt silver down
No,
to that
silver-
level. It's going to be, of course, create
it's you know, I should announce myself. I'm Jonathan Rowley. I'm giving a talk about
Okay.
3D printing at the end of the day.
Cool.
And you know, this is what is so difficult about this technology.
Right.
Is the way that it's presented, the way that everyone's given the impression that you can print anything in any material. It's a process. It's making.
It's a process, right? It's a
And
process.
you know what would interest me about that particular model is if we sent it as it is
Uh-huh.
to Shapeways,
Uh-huh.
would I get it back in silver 2 weeks later in 2 parts? Is anyone,
It'll be in 2 bits, yeah, because it's separated. The shell is
Right.
separated here, so you
And-
get 2 bits.
you know, if that's a pendant, that's an accident, correct?
Could be a design thing. They might want to do it later on. But you know, it's up to you as a designer to work out those. You know, we'll fix the meshes, but you need to obviously look at the screen beforehand and actually look at. This is why you've got a print preview, so you can see exactly what's going on, at the output level, so you can see that they're disconnected, so you then connect them up, and then you would go through that process again. So you're not committing to anything financially. Before you actually commit financially, you can go fix it, and then you can send it through.
Is there anywhere that says these are 2 colors, or these are 5 colors, so that you don't know?
By the fact that they're separate objects, there'll be
No,
two
this one you
objects.
can obviously see, but sometimes you're not really.
If it's connected and it's joined, it'll be a single object.
Yeah, so is there somewhere that says this is a single?
Not at the current time, no, not at the current time.
You cannot run like you cannot run a check on the file to actually see whether it's working like before you actually fix it, because sometimes you might want, like you said, it fixes the
Right.
thin shells, it thickens them up. And let's say if I model a cup which has a hole at the top, maybe I just want it to be a shell, a thickened shell, rather than close the hole on top and
Yep.
have a cylinder.
Yeah.
You know what I mean?
Yeah, so if I would take the top off and have it as a separate component next to the cup, and then have the cup as a unit, it will then print as a shell, and then you'll get the second piece of it. If you put them together, the problem when you put, I mean, you could put it inside, because some,
Imagine a vase, but with a hole at the top.
Yeah.
The shell is thin. It's only one polygon shell.
Yeah.
It's non-watertight mesh, basically, with a small hole at the top.
Oh, that's fine. We'll look
Will
at that
it
and
close
we'll.
the hole, or will it
No,
just
no,
keep
no.
the
It'll
shell?
keep the hole open. It'll keep the hole open.
Because some slicers that
They'll
see
close
that
it off.
as a problem, and they just close the hole.
So NetFab will
Some
close it off.
slicers will,
Yeah.
will tell you that it's just too thin and you have to fix it yourself.
Correct. So NetFab will close it off. We'll keep it open and that geometry. As long as it's a closed mesh, next session I think. As long as it's a closed mesh, so as long as there are any holes that are not closed in the 3D geometry, we will then, if it is open, we'll fix that geometry. If it's designed to be open, we'll keep it open.
Yes.